Welcome. Today I would like to share you about the Douglas XB-19, the vast bomber, the Douglas B-19 Behemoth. Active from 1937 to 1941, was a groundbreaking experimental long-range bomber and held the title of the largest aircraft built in the United States during World War II. In the mid-1930s, U.S. Army Air Corps sought a formidable flying fortress capable of striking targets thousands of miles from America's shores. This ambitious request led to the development of both the Boeing XB-15 and the XB-19. When these aircraft first took to the skies, with the Boeing B-15 debuting in 1937, they were the largest in the United States. The B-19 was constructed in the expansive hangar of the Douglas plant in Santa Monica, California. Its immense size was exemplified by a wingspan of 212 feet, slightly surpassing that of the modern Boeing 747-400. One of its most notable features was its enormous main landing gear, which was equipped with 24-ply tires measuring 8 feet in diameter. This colossal bomber was a symbol of the era's ambition and technological prowess in aviation. XB-19 shrouded in secrecy. The Douglas XB-19, one of the most ambitious aircraft projects of the early 20th century, stands as a testament to the era's engineering aspirations and the evolving capabilities in aviation. Initially conceptualized in the 1930s, it was the largest bomber built for the United States Army Air Corps' USAAC until that time, designed to meet the demands for long-range heavy bombing capabilities. The XB-19 project, initiated under the designation XBLR-2, experimental bomber, long-range, was shrouded in secrecy due to its strategic importance and the technological advancements it embodied. The origin of the XB-19 traces back to the Air Corps' request in 1935 for a super bomber that could carry a significant payload over an extended range. This request was part of a broader effort to enhance the USAAC's capabilities in response to the growing geopolitical tensions of that era. Douglas Aircraft Company won the contract to build the aircraft, and the design process commenced under the leadership of Donald Douglas and his team. The project faced numerous challenges, including engineering hurdles related to the size and weight of the aircraft, as well as budget constraints and shifting military priorities. The XB-19 was characterized by its colossal size. With a wingspan of 212 feet and a length of 132 feet, it dwarfed most other aircraft of the time. The initial design called for a payload capacity of 18,700 pounds and a range of approximately 5,200 miles. Figures that were groundbreaking in the late 1930s. Power plant. To power such a massive aircraft, it was equipped with 4 Allison V3 42011 V2 engines, each producing 2,600 horsepower. The aircraft's size and power plant choices were indicative of the ambitious nature of the project. The construction of the XB-19 was a lengthy and complex process, partly due to the experimental nature of many of its features. The aircraft included innovations in wing design, propulsion, and load-carrying capabilities. Its vast wings were equipped with Fowler flaps to aid in lift generation, a critical feature given the aircraft's weight. The use of a tricycle landing gear system, a novelty at the time, was necessitated by the bomber's size and weight distribution. The XB-19's development coincided with significant changes in global and domestic contexts, including the onset of World War II. These changes impacted the project in various ways. Initially, there were delays and debates over the continuation of the project, given the rapidly evolving nature of aerial warfare and the aircraft's high development costs. However, the USAAC proceeded with the project, recognizing the value of the XB-19 as a testbed for new technologies and concepts in heavy bomber design. XB-19 Maiden Flight. The XB-19 finally took to the skies on its maiden flight on June 27, 1941, from Cloverfield in Santa Monica, California. The flight, piloted by Major Stanley Umstead, was a success, demonstrating the aircraft's capabilities and providing valuable data. Despite its successful test flights, the XB-19's role in the USAAC's strategic plans was limited. By the time of its completion, more advanced bomber designs, such as the Boeing B-29 Superfortress, were already under development. These newer designs offered superior performance and were more aligned with the emerging needs of aerial warfare. Throughout its service life, the XB-19 was used primarily as a test platform. It provided insights into large aircraft operations, including flight characteristics, maintenance requirements, and logistical support challenges. The data and experience gained from the XB-19 project were instrumental in the development of subsequent Yosemite heavy bombers and influenced various aspects of large aircraft design in the following decades. XB-19 significant contributions. The XB-19 was eventually modified to accommodate more powerful Wright R3350 duplex Cyclone radial engines, replacing its original Allison engines. This upgrade was part of the ongoing experimentation and testing that defined the aircraft's operational life. Despite its limited role in combat operations, the XB-19's contributions to aviation technology and bomber development were significant. It pushed the boundaries of aircraft design and demonstrated the feasibility of constructing and operating extremely large bombers, a concept that would become crucial during and after World War II. The Douglas XB-19 was ultimately retired in 1949. Its retirement marked the experimental aircraft design, characterized by bold ambitions and significant technological leaps. While only one XB-19 was ever built, its legacy in aviation history is marked by its contributions to the advancement of heavy bomber technology and its role in expanding the limits of what was considered possible in aircraft design at the time. The Wright R3350 Duplex Cyclone. The Wright R3350 Duplex Cyclone, an American aircraft engine, is a twin-row, supercharged, air-cooled radial engine with 18 cylinders and a displacement of nearly 3,350 cubic inches, 54.9 L. Its power output varied from 2,200 to over 3,700 horsepower, 1,642 to 2,760 kilowatts, depending on the specific model. Originating before World War II, the R3350 underwent an extended period of development and refinement before it was chosen to power the Boeing B-29 Superfortress. Post-World War II, the R3350 evolved significantly, becoming a key engine in civilian aviation, especially in its turbo-compound versions. It was notably used in the Lockheed L-1049 Super Constellation. Airliners throughout the 1950s. The engine's main competitor was the Pratt & Whitney R4360 Wasp Major, which had a displacement of 4,360 in 371.4 L and an output of 4,300 horsepower, 3,200 kilowatts. The Wasp Major was first run about 7 years after the Duplex Cyclone's initial development. In modern times, the R3350 is frequently used in aircraft like the Hawker Sea Fury and Grumman F-8F Bearcat, particularly in the Unlimited class racers at the Reno Air Races, showcasing its enduring legacy and performance. Survivors. Although the U.S. Air Force initially intended to preserve the B-19 for future display, by 1949 there was no established program for saving historic aircraft, and the Air Force Museum had not yet been constructed. As a result, the B-19 was ultimately dismantled. However, 2 of its massive main tires were salvaged. One of these tires found a home at the Hill Aerospace Museum, located at Hill Air Force Base in Ogden, Utah. The other tire has been prominently displayed for many years in the Early Years Gallery at the National Museum of the United States Air Force in Dayton, Ohio. These tires serve as tangible reminders of the B-19's impressive size and significance in aviation history.